Uh, the topic we are looking today is basically decision tree. So decision tree can be used to solve two types of problem, basically regression and another one is classification. So what these are, let us have a look upon it. So classification is a problem in which we have certain inputs, and based on the input we have to classify it into some classes, for example class A, class B, C and so on. So if we consider an example, for example, you have certain message as an input. For example, hey, how are you? How are you? And you have to classify it into some classes. For example, whether this is a spam or ham, basically not spam. So this is a type of problem which is called classification problem. Considering an example of regression. So for example, you have certain inputs. For example, you have years of experience of an employee, and you want to predict how much salary this employee will get. So this kind of problems comes under what we say regression. So how regression and classification are different. So in regression, you can have continuous input, continuous input, output basically. Sorry, and in classification, you have only limited number of classes. Classes A, B. For example, we had spam or not spam, basically a ham. So I think you must have got the basic idea of what is regression and what is classification. So moving ahead, let's come to a topic which is called decision tree. Decision. So what decision tree are? So to understand trees, you might have learned this topic in your data structures and algorithms. It's like trees represented as nodes and their childrens. Okay, this is called binary tree, right? And you have, if you have multiple childrens like this, not exactly two, but more than two or three or even four. So this kind of tree is called an array tree. So basically, a tree, a decision tree, also looks like this. Okay, a tree looks like this. So the question is how it basically works. To understand this, we can consider an example that will give us better understanding of this decision tree. So let us look at example. For example, first we consider classification problem. Classification problem, right? So what are our inputs? We have age as our input, age as our input, and we have to predict whether this person works, goes to college, or this person is retired. So what are our output classes? 1, 2, and 3. These are our output classes. So if you look at the input, this is pretty straightforward. Is an integer input or maybe decimal if we consider fractions, and you generate a scenario. Let's say if the age is less than 18, you can say, okay, it seems like this person will go to college, right? And let's say if the age is between 35 and 18, you can say, okay, it looks like this person might be working. Pretty logical. And consider an example where age is greater than 35. So it gives us a sense, okay, this person might be retired. This is a scenario. So how the decision tree will be formed in this case, right? So we'll move to next slide and try to form the decision tree for the same. So as we know, the trees contains nodes and basically edges. So we'll make our first root node, which will check whether this person's age is less than or equals to 18. So we have two possibilities here. Either this person's age will be less than 18, so we'll move to left of the tree, or no, so we'll move to the right of the tree. Okay. Then if the person's age is less than 18, you can clearly say, okay, this person goes to college. But if its age is not less than 18, then we have another check to run. Okay, if this person's age is between 18 and 35. So here again you have two options. Yes or no. Right? Yes, yes or no. So if this person's age is between 18 and 35, you can say, okay, this person goes to work. Otherwise, if we move to right side of the tree, we can say, okay, this person's age is greater than 35. So this person might be retired. So this is how our tree form is formed. So at every node we are making decisions. So let's consider an example to check our learning. Consider an example with age is equals to 15. I have to use another color. Let's say it's black only, red only. 15. So we come to this node. We come to this node and check whether the age is less than 18. And see, obviously 15 is less than 18, so we move to the left side of the tree, and we can clearly predict this person goes to college, right? It's pretty simple. Let's consider another example. Let's consider the person's age is 25. Now we move again to a tree. We came to this node and check whether this person's age is less than 18. We say, okay, no, the age is not less than 18, so we move to right side of the tree. Now it's not done yet. We have another decision to make. We come to this node and check, okay, whether this person's age is between 18 and 35. So what do you say? So obviously this person's age is between 18 and 35. So we move to the left side of the tree. After moving right, we came here and see, we can clearly say that, okay, this person's age is between 18 and 35, so this person goes to work. Let's consider another example for better clarity. 40. We again went back to a tree. We checked that this node, this person's age is less than 18, no, so we move to right side of the tree. Here we again check whether this person's age is between 18 and 35, no, so we move again right side of the tree, and we clearly said this person is retired. The output to this problem would be retired. So this is how the decision tree works. Okay. So before moving ahead, there is one question which comes to your mind. Let me write it. And it is one of the most important interview question, that where do you get the output of the decision tree? So this is the question. What's the answer? Look at this figure and make a guess. Okay. If you have made a guess, then I'll show you that you get the answer at the leaf nodes. It's clear from the picture that you get the answer of a decision tree at the leaf nodes, right? So the answer to this problem is, get the answer at leaf nodes. So what happens at, another question comes here is, what about intermediate nodes. If I take back to you the picture, okay, then you can see in the intermediate node, what is happening is you are making decisions. Basically, you are making decisions. The answer to this problem is you are making decisions. Okay. So this is all the basics of the decision tree. There are many things and many examples we can consider regarding the decision tree. Before moving, let me give you a disclaimer about some of the topics which we can cover next. Like, for example, some more examples of the decision tree so that you can get the better understanding. Some terms like what are pure splits, impure splits, what is the depth of the tree, and above this, another question adds that what should be optimum depth, right? Some performance based topics we can look forward, like how the features are selected. Features are selected. So we have some topics like information gains under that, and under that we have another two topics like entropy and Gini impurity. So these are the topics which we'll be covering next. This was just a disclaimer for these topics that with this all things we'll be learning next and discussing next, that what the thing, don't get confused or don't get like overwhelmed with the content. You'll be We'll be looking forward to each and everything out of this, and we'll be looking forward to learn each and every terms and the topics and discussion regarding that.